Welcome back to the Virtual Residency Workshop 2026. It is Thursday, June 25th, 2026, and this is our fourth and final session for the day. This is a panel on assessing and anticipating researcher needs. Our moderator is Carrie Brown from Penn State. Take it away, Carrie.
Thank you, Henry. Welcome, everybody. Let's take a moment and meet our panelists. Anna, can you introduce yourself?
Hi, my name's Anna Klimaszewski-Patterson. I'm a professor of geography at Sacramento State University and the director of the Geospatial Lab.
Thank you, Anna. Chris.
Hi, Carrie. It's nice to see you.
You too.
It's always nice when I meet you in person, but I'll take this. I'm Chris Reedy at the University of Arizona. I manage the support services for our HPC. I've been on the systems team for a number of years, and now I manage the facilitators.
Thank you, Chris. Stephen.
Hi, folks. My name is Stephen Oglesby. I'm the Director of Technology Delivery with Tulane University, and that's sort of the fun way they describe delivering aligned technology solutions to researchers across HPC or data platforms. Thank you.
Thank you. Evan.
Hi, Evan Limley at the University of Central Oklahoma. I'm the Dean of the College of Math and Science here, but I'm still serving in and got our High Performance Computing Center started a few years ago.
Thank you so much. And our last panelist, certainly not least, Joe.
Hello, everybody. I'm Joe Mochnik. I'm a professor at Kansas State University. I'm a senior advisor for innovation and AI, and I have been involved in research, data management for a good chunk of my career, but my kind of home is in history and in libraries.
Welcome. So for all of our participants today, I want to say that, and correct me if I'm wrong, panelists, I think we want this to be a very conversationalist panel. So if anybody who's attending has feedback, thoughts, comments that you'd like to share, go ahead and raise your hand and we'll just take a moment to call and allow you to unmute and share what you want to say. Otherwise, we're going to, I have a few questions we've prepared I can throw out here to just kind of get the conversation started. So first is, when talking to researchers, what approach do you find works best to get a clear understanding of their needs versus wants? I think if you guys would like me to call on you, I'm happy to do so. Otherwise, feel free to just jump in.
Well, I'll jump in here. I think the first thing is to be a listener, to be open to what they have to say. I will sometimes, I have kind of regular coffee meetups that I do with researchers. I'll have a list of people and then I'll send them an email, say, hey, do you want to meet up for coffee sometime? And they almost always say, yes, I've only had one ghosting experience. And then just meet for coffee and talk. And in that conversation over sort of a relaxed atmosphere, I'll ask them what they're doing, how it's going, what their needs are. And I'll mention a couple of the initiatives we are either thinking about or looking to actually implement and get their feedback on those. In a relaxed environment, they're more likely to express openly what they think as opposed to pursuing a strict agenda.
Yeah, I love that idea.
So I'll chime in as the faculty member when you're talking to them. We tend to have tunnel vision and we have what's going on in our mind happening at that moment. And then that's what we're going to tell people. And that's the problem. This is what we need fixed. This is what we need resolved. And usually they'll tell you what's wrong and what they want. But the thing that you ultimately have to do is go, what are you trying to do? But you can't say, what are you trying to do? Because they're like, I'm trying to just get this to run. Because that's, what are you ultimately trying to achieve? What is it that you're trying to get at the end? And then that kind of takes us out of our tunnel vision. And it makes us think, well, what is it that I'm trying to achieve? Because we'll tend to, the more you're frustrated on a singular problem and having a whole bunch of other, I don't have time to do research. I don't have time to teach. I don't have time to be meeting with my students. I have to do all of them at the same time. I just want this stupid thing to run. Then if you can just kind of get them out of that headspace of what is it that you're trying to accomplish instead of feeling like pressure is on them all the time, that's like, oh, well, I'm trying to ultimately get it to do X, Y, or Z, then it's like, okay, that might not actually be the best approach. The thing that you're fighting isn't actually the thing that you need to be fighting. We need to go back a couple of steps and either take a different route or try a different tool, or, oh, yeah, there was an update. Let's just run that and see what that does. Or, oh, there was an update and it broke things. Let's roll it back and see if that gets you to where you need to be. So it's kind of almost like working tech support when somebody's calling you and you're working at like Comcast or an internet provider. The first thing you do is go, hi, what's your name? What's your thing? Just to kind of break them out of that anger. Well, the same thing with faculty. You kind of have to break us out of the tunnel vision that we're in of, I just need to get this to work, make it stop fighting me.
I can go next and I can add a couple of thoughts here. I think that one of the best successes is really to somehow connect the opportunities and the services that may be potentially offered to be their idea, and really kind of to switch it on them, and to somehow hope that in this conversation, certainly asking questions, listening very carefully, and coming to a stage of conversation where they can kind of express and say, well, this is where I am at, and somehow being able to meet them at the stage with the greatest point of need, and really kind of somehow they have a sense of ownership. The moment they have a sense of ownership, you are off to a good start. You really are able to move forward. So try to really push it aside, whether it is your idea or not. And frequently it's not my idea, it's somebody else's, but somehow acknowledging that it's actually their idea, that it's their needs, that their initiatives. I think then it can really make significant difference as you move forward. So kind of given all of the other things that have been mentioned before.
Absolutely.
I'll add to that. I appreciate what Anna was saying about the researcher that just wants to focus on the problem to be solved and the problems that they're having. But most researchers want to talk about their research. And so that's what I really like to do, is to get them, maybe sometimes a couple of slides even about what they're doing and how it works and what their workflow looks like, and really what are they trying to get out of it, as she said, and then but usually once they start talking about what their research is about, they're very passionate about it, and so letting them focus on what they want to achieve and their passion for it, usually learn a lot about the research, number one, which can be really helpful to help guide them, and then what they're doing now, and then what they ultimately want to achieve. That combination seems to really get the most bang for your buck in those discussions, it feels like.
Absolutely. All right.
Oh,
Go ahead,
I
Stephen.
think sorry, I just wanted to add on as well. From my perspective, oftentimes, right, when we're talking about cyber infrastructure or data platforms, it tends to be really talking around what is something that we need in the first, phase, we'll say, and then how do we prioritize what needs to go to the second phase? What do I need in 6 weeks? What do I need in 6 months? And I find like talking about it in phases tends to make sure that we're not encompassing everything that I might look into for research direction, as far as like trying to figure out how we get the right data use agreements for the idea that I have a year and a half from now at the end of this contract, right? So while we want to, understand that underlying vein, like trying to think of that phase approach, I think sometimes really sharpens the conversation. For a lot of the software stuff, we'll try to do, it's like Moscow, the must have, should have, could have, that kind of stuff. And you try to walk through like what are the things that, again, sort of we need to have, what are the things that would be nice to have if we can find that solution that aligns with it, and then kind of work it back through there. So as far as like really specific tactics, that's some of the things that we've done before. Thank you.
Absolutely. I like that reflection of what do we do now? What do we do in the future? And I think that leads into the next question I was considering, which is how do you balance researcher needs with like staff availability and workflow or workload, sorry. So I think, having that initial conversation and prioritization would obviously do it. Does anybody else have any other strategies that you utilize?
We were instructed not to leave dead air, so I feel like compulsion to talk. The one word that I have that helps balance those two is documentation. My staffing is restricted. We have about a 15% growth rate and usage, but I haven't had any new staffing at it in 3 years. So we make up the difference by collecting the frequently asked questions and figuring out how to present it in our documentation. We try to present it in multiple ways. It may be from a recording of a workshop, a focus section on getting started, a quick start guide, FAQs. Find if you offer the same information in multiple formats, something will stick. And since we rewrote all of our documentation, our ticket count has actually flattened and slightly decreased. And looking at Google Analytics, I believe that's because they can often find the answers in the documentation and don't have to open tickets to us.
Absolutely.
I
Yeah,
agree with.
I'll take a shot at it. I think, we have a very small staff devoted to research computing at my institution. And so, we even though someone might technically be a system administrator, they're doing research facilitation to some extent. They're helping researchers with their code sometimes. They're helping deploy hardware in our small data center, sometimes with networking. They're doing a lot of different things. And so the balance is very tough, and overseeing student employees too. And so, I think as Chris mentioned, the documentation can be really helpful. We've done more and more so users can be self-sufficient. But really helping in sometimes key, one or two key staff members um, work through their time management is a part of this too. And sometimes they might be experienced, but they might be kind of new to working in that role. And so sometimes former students have occupied that role for us, and I assume others run into this too. And so you're kind of in that in the now you could have a researcher that occupies too much of their time, in which case you might have to help them understand that they're going to have to limit their requests. Not We haven't run into that all that much, but on occasion that's come up. And so to me, it's more working with helping often that in our case, small number of staff members sort of grow in their positions.
Nice. Stephen, did you have something that you wanted to add?
Yes, I actually really agree with both points, especially Chris's about documentation. On our end, a lot of the focus has been around, if we answer a question once, how can we make sure that answer is proliferated across the entire university as best possible and accessible there? I think a second part is just, hmm, I've worked with a lot of folks, and we all do, that are really passionate about the research space. They want to drive solutions. We're excited about these projects. We're excited about solving these problems. And so what I find is just making sure that we're able to push that passion into the problems we're the strongest at solving. And so sometimes I found that, we'll get kind of swept into is this the right, data for the system conversation, which maybe could go, more to another party, or it should just be more of a data management curation libraries kind of topic of conversation. And so we're just a little bit weaker as opposed to let the computational scientist that's helping with a new pipeline, where that we're really strong at, and just focusing on those things.
All right. So how do you anticipate, or what ways have you used to anticipate what researchers will need, in the near future? And I guess I'd like to challenge us to think beyond just what we ask the researchers. How can you identify needs that they may not even realize they need yet?
We've actually done quite a bit of work in that space in our group around being more involved in kind of the proposal process and grants lifecycle management on the one end, but also trying to ensure that we're flagged on procurements as well, or interest to procure. And so some of that has helped to open up conversations where this person is buying, $60,000 in desktop hardware. I wonder what if they know about our shared services around computing. And then at the same time, right, kind of chasing newspaper tabloids of this researcher recently won a grant that was in the proposal pipeline. We had some awareness of it, but hey, it's awarded. This is great. How can we introduce ourselves in a friendly, non a friendly manner so that we can kind of see what services we can offer and kind of leave that option up to them. We want them to be aware of us and not, I guess, pushy, at least from our perspective.
That's great.
I think,
I'll
sorry.
agree with that. Sorry, I was just going to agree with that on if you can get in on the pre-award side, so that way the pre-awards people go, oh, there's something here that might be of interest for the facilitators or for IRT or IT, and get them to help you reach out to those people or know who those people are to then be able to reach out to them. It can head off a lot of headaches later on, both for IT, but also for the researchers of what do you mean this is a roadblock and I can't do it? What do you mean we don't have this? What do you mean I can't do that? And they'll write it into the proposal thinking, well, of course I can. We don't take no very well. So if we know ahead of time, then it's oh, well, that never even occurred to me. Of course, yeah, we need to write in resources for IT or whatever, because a lot of times they don't even necessarily think about that. And it depends on how large your institution is, um, what the background knowledge is going to be for a lot of your faculty members. But most of the time, we're not keeping abreast of those things. So it's nice to know.
Absolutely. Evan, did you have something to add?
Yeah, I was going to say that, and sort of taking it in a little, I hope I'm answering the right question, but a little bit different direction. In that, to me, and I was a faculty member for a long time doing research, computing related research too. But even since that time that I was doing that, what I like to do is to be very aware of the research that's going on my campus. And admittedly, we're not a large, extremely large institution, and so that's a little easier to do in my case, maybe. But knowing as much about what the researchers are, the kind of research that's going on, the kind of computational needs they currently have, and then really being, out there, going to as many conferences, as many interdisciplinary STEM conferences as possible, where you hear a range of kinds of different research talks, so that you hear what's, being kept aware of, and read papers as much as you can too, but stay aware of trends and directions things are going, so that I can't remember, or I recall many, many times being at a conference and being on my laptop or phone, sending, finding the abstract for a talk and sending it to a given researcher saying, oh, this is is this related to what you're doing? And is there something that, it was really cool what they were able to do with this resource or something like that. And that leads to discussion later a lot of times about what they can do next in their research. And I think it helps start to see the edges of what they might do next and what the hardware and software we're going to need to do to support that is.
Yeah, I think that's one of the most exciting things about, at least for me, being in research computing, is when you suddenly make that connection and you find some new bit of information that you know is just going to make someone's life easier. It's definitely very rewarding.
I
Um,
like Anna's comment about the getting involved in the budgeting and grant process. If if I can get involved as being like the relationship person with the vendors or with the technology and be help drive the architecture for the grant proposal, then like we're really in it at the ground floor. And then to Evan's point about listening at events, I think our community, the people here at this event, are a great source of ideas. And I was just at an event last week, and the subject of computing came up. And I was like, oh, yeah, we're 5 years away. Okay, that's what I hear. But the message was, we may be actually 3 years away. And if you don't start teaching your students now, when a practical quantum computing industry starts, because now it's actually feasible, the students won't be ready and they won't be knowledgeable. So they may not realize, to your point, that there is going to be a need out there and they should start learning now, and that we can be part of the facilitation for their learning. And I've got a lot of work to do to make that happen. But in our community, there's a lot of information out there that I can draw on.
Absolutely. All right. Now, I'm going to switch topics a little bit and talk about how to balance the researchers' desires with just needs from the former sectors, or from, the nuts and bolts of running a secure research computing environment. So, for example, oh gosh, where did it go? So if you have users that have always used the same workflow for decades and years and they're unwilling to update it, how can you help accommodate them? And I have to bring this up. We have a faculty member that we work with who has this code base he uses. Every time we update the system, it breaks, and we have to work with him to get it back up and running. And it's such a source of frustration for him and for us. So how do you work with those users? How do you convince them to either change what they're doing, or, is there a way to meet them halfway?
Usually, if we're running something for decades, there's a reason why we're doing it, and that's because either A, there's nothing better, nobody's come up with anything better, or the better doesn't actually do what we need it to do. Like the number of times that we've had software, it's like, wow, mine worked better 20 years ago and I could do more stuff than the new version. Fantastic. Thanks for the upgrade. Or two, they don't have time to learn a new system, and they don't necessarily trust a new system. When we had time was when we were grad students and we invested a lot of time, energy, and effort into building the workflow. And as faculty members, we don't have that time or energy. And you only have a grad student for a couple of years if you even have a grad student. We don't. But if you have grad students, now you're trusting them to have documented everything so that way you can continue to run the workflow. And if nobody's documenting it and you have no idea how anything works, you're going to go back to the way that you know does work because you don't have time to be dealing with trying to figure something out. So if you're trying to get them to upgrade, you have to provide options or do a little legwork of your own, and not necessarily ask them to be doing these upgrades during the academic year when they don't have time, or during, sometimes it's they have time during the academic year but not during the summer because that's when they're doing all their field work or their research. It depends on the individual person and the kind of research that they do. But if they're sticking with something, it's not because necessarily they're being obstinate. It's because they either haven't seen anything better or they don't have the time to invest into upgrading it, and they just want what they have right now to continue working. And please quit causing them friction. So the less friction, or the friction, if you can take even a little bit of friction away and you insert it somewhere else, but you take that really annoying little friction part away, then sometimes it's the I'm willing to do all this other stuff if it makes this constant annoyance go away, sort of a thing. So being able to help facilitate that, finding what that mechanism might be, is usually the best way forward, I've found.
I love that.
I'd like to relate a success story we had. 10 years ago, we had three different supercomputers to do kind of three different things. One of our most influential faculty on campus was a climate researcher. She's very influential, of course, because of her domain, but she has a forceful personality, and she was quite insistent that when we bought a new system, that it would have an SMP system inside it, would be one of them. Now, you may not know what an SMP one is. It's symmetric multiprocessing, and the reason you may not have heard of it is it's not around anymore. They're very expensive, and they're pretty much being replaced by high memory servers. So now you can buy a server with 3 terabytes of memory, and it's not that big a deal. I think even a 1U will do that. But 10 years ago, it was the thing if you wanted to do lots of memory. So how would we buy something? How would we avoid buying $1 million item like that, and which would take up a lot of our budget for the purpose, but still satisfy her? So the compromise was that we would buy a generic system where all of the compute nodes are the same, but we would pay for software which would aggregate a number of the nodes together to be a virtual SMP machine. So that solved her requirement. When that software never really quite worked, we just turned all of those compute nodes into standard nodes and took that virtual software off because it just didn't really work. By then, she was fine with the system that we had, and she wasn't pushing anymore on the having that carved out separate machine. So our system had all of the nodes all the same, with the exception of a high memory, and then later on we bought GPUs. Um, and to tail off the story, and Evan, you might be interested, we are donating that 10-year-old system to the Oklahoma Friction-Free Network. I think that's Stephen Wheat is running currently, and Henry is very familiar with. So our 10-year-old system still runs fine, and it's going to get a new lease on life.
Oh, that's great news.
Yes.
I
Cool.
expect Stephen will let us log on too, maybe. I don't know, but
Yes.
that's
Mhm.
cool. Well, it turns out I was at a meeting earlier today where this is quasi HPC, not totally HPC, where a unit in my college wanted to operate some new hardware in a certain way that was not really attached to our cluster. And um, not to say all the problems are resolved yet, but we really wanted to demonstrate. And so it was a matter of demonstrating to them sort of and the way it would be operated would really not even use a queuing system, wouldn't use Slurm, be very manual assignment of hardware to particular individuals and other kind of things that we wouldn't see on a cluster typically these days at all, but just was sort of how that they were accustomed to operating certain things. And so really it's just a matter of explaining how Slurm worked, and sort of taking the load off of individual faculty having to prepare different environments for some Conda environments and some other things, and just showing them that, oh, well, we've already got that, and really I had one of my staff members at this meeting who had done a great job preparing, and just to show them, oh, we've pretty much already got it set up the way you mentioned you wanted it. And so we just demoed that. And then I think at least a couple of them were kind of blown away by that and thought, oh, that takes the load off of me setting it up. And so we're very, very happy to say, consider at least maybe operating in a new way. So with a different workflow. So it was sort of that meeting where we just had to show them and really understand what they needed and also show them what's already in place.
Absolutely. All right.
Uh, I wanted to again kind of piggyback off of Dr. Patterson's comment around, availability of graduate student labor and to explore new topics or not, right? And that is actually kind of a focus point of a lot of our like new HPC instruction is awareness to the principal investigator and the faculty member, sure, but as far as how to use it, what are the cool features, how does open on-demand work, right? A lot of that's graduate student focus. The thing that I might add that we do that's a little unique is we created sort of researcher personas, so to speak. So what we found were, there's 3 to 4 to, 15 material scientists of sorts. And so they're looking at it from this vein. They use this type of software. There's kind of 3 or 4 heavy hitter packages, and, they kind of have this data footprint. And then there's another one for genomics, and there's another one for another group. What that allowed us to do is like when we're dealing with upgrades or when we're kind of talking to individuals that are coming to the university about like what this might look like, we kind of have an example to point at that's readily available, and it also kind of helped whenever we're talking about, well, what does it mean for us to move to from 14 to 15 for versions, or some of those other pain points. Well, we kind of have some awareness based off of like reporting that, okay, there are successful version 15 users, and what does that look like for your department? And kind of, I don't know, sort of make it more of a group activity in that way for folks than sort of one group that feels like they've got to lift themselves. And I think that depends on the size of the institution, but that might be helpful.
Absolutely. So I kind of on that line, because you mentioned open on demand, Stephen. What are some of the strategies that you use to serve less technical end users, or interactive jobs? So besides open on demand, are there any other offerings that you have that are specifically targeted to those people that don't necessarily come in, being completely proficient at Linux or writing batch scripts?
For our group, the sad answer is no. We we end up trying to push a terminal and a command line early and often, which I don't know if that's the best move. We do have some open on-demand access, but um, everything that we push as far as trainings and across the board is generally terminal and SSH based.
All right.
We are primarily using open on demand and trying to put as much there as we can. Mostly those are interactive jobs, but probably not all. And some consuming quite a bit of resources, but some not that much. We do, um, offer all classes at the institution the ability to use Jupyter Lab and other platforms for the class environment and not just research. And then we do have some users that are going to go terminal and SSH in, but then really for us, the bulk of our users don't do that until they realize that they can pipeline and make things more flexible and more efficient doing it that way. And then usually once they learn to do it, they want to do it that way. And so it's not everyone gets to that point, but quite a few do.
Yeah, I would second what Evan said there. We're in that exact same situation that open on demand just makes things easy for them. So many users use Jupyter notebooks. It requires us to monitor more carefully because they will have that aptitude, I guess more attitude is the right word, of I found something that works. This is what I'm going to keep doing. So at some point they should be doing batch submissions, Linux scripts, Slurm scripting and submissions. And so we will give them nudges towards that documentation training. We'll help them at office hours to move over to running jobs through batch because it's going to be more efficient. Um, we have learned to watch for people who park on a node, especially GPU nodes. They'll request a session and then 6 hours later, maybe their session shows up. They've requested the maximum runtime, and now that's their GPU for the next 4 days. Our overall run limits for batch are 10 days. So we've had to shorten the limits and tighten the limits for interactive open on demand to prevent people just parking on nodes and trying to make their life simple, but sucking up resources that other people need to use.
So for those of you who have who do that, so exactly as Chris described, where they will start in that interactive environment and then they hit that point where the only way they're going to be able to scale further or make things more efficient for themselves is to learn how to do things on the command line. What is your approach for helping those users? Do you sit down with them individually and assist them? Do you have like a bulk of resources that you just throw them at, or like what do you do?
The way we describe it on our end is a lot of our trainings are, I'm going to say Rosetta Stone format, where we show the same task in 5 different ways. So, right, we've moved the file in open on demand. Great, you see it on your desktop. Now let's move it in command line. Great, you see it on your desktop. Now let's move it with Globus. Great, you see it on your desktop. And kind of the same activities happen with Jupyter notebooks or with using R versus RStudio, where we run into those classes where folks really want a user interface and just don't realize that all the heavy lifting of their scripts and everything are still applicable in the HPC system.
One thing we've been trying to do is to include, there's a job composer in Open On Demand, include more templates that, as we see examples of different Slurm scripts and other things coming through, other batch scripting techniques, we tend to try to make that into a template that's available in Job Composer. I'm not sure how much that's getting used, but that is something we are hopeful that would be helpful.
Okay, absolutely. We do the same thing, but we have a GitHub repo and I throw that at everybody I ever meet with. I'm like, here's all our example scripts. All right. One of the things that I don't know about everyone else, but data security is a really big topic right now, right? And how do we balance that in this in the openness and collaborative nature of science? How do we maintain the security and shared infrastructures? Stephen?
That is sort of sorry, that's a session all by itself. But the way we've looked at it is around in I guess intentionality. And so if it's open on purpose. It is open. If it's secure on purpose. It's sort of what we were finding in a lot of the discussions is I have this amalgamation of data and I need to share something, so I'll just share all of it, right? And so like those are the parts where we found like concerns and sticking points. The second part was around really just talking more about what I would term like compensating controls. So, right, just like an HPC, maybe we don't have a lot of firewalls or we don't have a lot of this. So like for us, we send monthly reports to our researchers to assess like access control, essentially. I mean, we phrase it nicely. It's phrased differently, but it's around these are the 18 students that look like they have access to your shares. It looks like 6 of them could have graduated. Do you still want all of these on here? Are you still friends with all these students? Usually they are, right? And so kind of just trying to do some of that show back stuff so that they have that awareness and can really control their data and manage it appropriately has been big for our kind of security footprint there.
I like the idea of the scripting and monitoring. We found out from one of our, actually, it was a student. They said their VS Code, they sort of run out of space to put things. They were putting things everywhere. They put things everywhere where researchers had not tied down their file permissions. We found researchers with 777 permissions. And so for the non-sysadmins, that means anyone can read, write, execute, or delete your files. Anyone who is logged in can do anything to your files. So we now run a weekly report and look for anyone who has bad permissions and send them an advisory like a form response. So being proactive, I think, is really important. Joe, I see you went off mute, so let you jump in here.
Let me add a couple of thoughts. I think kind of being reminded that the data has life cycles, kind of like we do in same, very similar ways, kind of like there's a gathering of the data, kind of synthesizing, organizing the high value data as it's being utilized, and then somehow gradual archiving or potentially sunsetting of those data. Nothing lasts forever. I mean, unless some things do last forever, longitudinal studies and such. But kind of really being very cognizant about there and having very very gentle but somehow very intentional conversations and acknowledging kind of like how the value of some of this research data really moves up and moves down and kind of transitions. I think the whole idea of that some of this data could talk to each other or could be compared with different institutions is quite important at that time. But really, taking a step back sometimes and kind of acknowledging the limitations of the file size, limitations of the drive size, limitations of the access. I think some of the regular things that sometimes we take it for granted and you kind of say, "Oh, it has to be there." Of course, it has to be there. In perfect world, frequently we don't live in that perfect world, and really trying to kind of engage with researchers and going this step further, kind of like how things transition. So unless it's of a high priority for the institution and the longitudinal studies continue going on long after a particular faculty or a group of faculty transition out and they're being replaced by somebody else, then you can have those conversations and say, hey, is there some kind of a archive or dark archives where you can put that and really leave it aside so it's not right in front of you, and find the way how we can manage that. So anyhow.
Are there any special considerations that you guys do in specifically because of, say, like the increase in AI? So with these AI coding tools, are there certain guidelines or guardrails that you have in place to prevent, unintentional bad actors?
The nice thing about my university is I'm part of the California state system. So the chancellor's office said everybody has ChatGPT. So how do you make everyone hate something? Give it to them and force it down their throats. So pretty much nobody at my institution is wanting to do anything related to AI. And if they do, they're very clear of no, no, this is machine learning. This is something different because the general public doesn't understand that ChatGPT is nothing but applied statistics and machine learning has been around for a long time, and that there's like 7 different kinds of AI, but they all kind of get lumped under one really big umbrella that nobody understands.
Yeah.
And even with ChatGPT, and even though we have a tenant, people don't necessarily understand who does have access to the data that we have up on our tenant, what does go publicly available. Oh, I wasn't logged in. That's publicly available. Oh, I was logged in. That's in our tenant. Just trying to get them to understand that is already in and of itself a chore. So fortunately, the faculty of ours that have been using AI actually understand what it is that they're doing because they're doing machine learning and they're actually building the models properly as opposed to going, ooh, magical bullet, let's just do the thing because ChatGPT is just magic. And it's not the same thing and it's not as secure as everybody's thinking. Yeah.
It's kind of funny. That's one way of keeping LLMs off your HPC is that method. We're lucky that the VPR's office has provided LLM support through AWS Bedrock. So if people want to do LLMs, they go there and they don't come to us. So we're very relieved that we're not like buried in LLMs. And the notion of, I heard it earlier today. I told Gemini to create a code to do this job that I want done. Now I'm going to run it on HPC and just the things that it could do unfettered is kind of scary. So yeah, right, Anna, like, oh, don't do that. So the more they stay off and just stick to machine learning and what we consider to be AI is better. But we don't really curate what codes people run because it could be their own codes they've compiled, it could be community codes, paid codes, the whole gamut. And we don't tell people what they can and cannot run. We just expect them to abide by our formal university practices and our HPC policies.
All right.
Hey, if I can just jump back, sorry. Oh, Stephen, go ahead, and then I'll go back to what I was thinking.
Oh, no problem. I was just going to mention on our end, I would say a lot of our researcher focus has been kind of on the inferencing and sort of we're going to say like the ChatGPT style of with different types of augmentation in those systems. And so because there isn't as much like model development in the same way, at least today, uh, we've really been able to reference it as sort of just like data use agreements, data policies about like where clinical data goes, that's an existing one, or what we're allowed to do with this research. A lot of our work has been around like sandboxing within Azure for an environment for that sort of thing to take root. But it's not novel like HPC. We're going to build a new small language model kind of stuff at this point.
So we have so for security and like Stephen mentions, just what you will allow and won't allow. We have best practices and the systems team are really good at those. So we have a Bastion host where you log into, you have to use a VPN from off campus. So we let VS Code users run an SSH into the nodes because they've been sort of validated their access. Um, we have learned a lot from going through the HIPAA and CUI processes because those are very strict on your practices and how you implement your systems. So we've applied a lot of what we learned from that onto our general HPC.
Okay. What, besides the ones that we've discussed, what are some of the biggest cybersecurity threats that you see to HPC systems today, and how do you attempt to mitigate them? So,
Uh,
Stephen, yes.
oh, sorry. On
You
our end, what
unmuted,
we've
so we just
yeah, yeah,
pounced on
you're
that.
all right. Um, on your, I guess on our end, we really have kind of thought around kind of account compromise and sort of data egress, right? And those are sort of tied together, right? Usually there's an account compromise and then you lose data. And so then it's based off of like what the space of data that they have access to or potentially have access to. So with that in mind, a lot of our work has been sort of that show back of like access controls for the PIs. We've talked a lot about like annual inactivity, which feels weird to me because right at the same time you want to show, hey, I have 800 users on my platform, but I want to make sure that that's, the number of users that are relevant and active that have, business going about work on the system while being respectful of like sabbaticals and, every life in between for a researcher because it's cyclical. So that's been a big portion of it. And then the other part is been probably the most difficult, which has been around really kind of data retention. And so enforcing more of a purge policy, for lack of a better term, data retention of inactive data after a period of time. So like a year and a half. And and so that's what we've done to kind of shrink that footprint at our institution.
One of the things that I see with our researchers is some of the mechanisms to retrieve data and or even open source AI models have been concerning. So for an example, we have a researcher that wants to use Reddit data and wants to use academictorrents.com. However, our Office of Information Security is like, no torrents at all, ever. And we're like, I don't understand how else he's supposed to download this 3 terabyte data set. And so it's trying to balance the desires of those researchers to have access to all of those open tools and data sets that are out there, but to kind of protect them from themselves from, you know, because they want all the doors open, right? That would put us at risk. And so, yeah, it's a fun balancing act. Um, so along this thread of predicting what we'll need, what additional innovations do you think are needed to help maintain data management and storage at the level of which HPC scale outputs are producing them?
I'm not sure if this is an innovation, but we have all of our main storage is all flash. It's limited in capacity, and the budgets worked out wonderfully 5 years ago when we bought it. We would not be allowed to buy it now because it cost over $1 million. But I calculated that our throughput on our system went up 20% because we were no longer bound by I/O weight. Um, all flash is all I/O all the time. We look for the hotspots when a bioinformatician is writing 1 million files into a single directory. And the spikes that occur don't get noticed. It just works. So if you can afford a lot of flash, it's wonderful. These are terrible times to buy anything, but storage in particular, because of the NAND inside a flash or even with hard drives is just crazy expensive. But maybe in a year, the prices will, the market will revert and be more normal. So having some degree of flash is really good. And some of the vendors have very I don't know about creative, but they've got very sophisticated architectures, so you don't have to buy the most expensive to get really good performance. Um, so if you consider that a storage technology, then performance really helps.
Absolutely. Uh, does anybody else have any like needs that they're seeing in their researchers that isn't met yet? Stephen?
Um, the, I have an unpopular opinion maybe to share about this. And so I would love feedback on this from panelists as well, but I'm kind of wondering at this point, um, like whether there needs to be some sort of, I don't know, like data prioritization based off of a level of curation that occurred. And so I've been finding at our institution and other folks that I've talked to, right, there's a lot of interest in if I have this garbage bag full of data, so to speak, and I throw a little sprinkling of AI over the top, I suddenly will get great results. And I don't necessarily believe in that in the same way in my experiences. And so my what I'm wondering is ultimately, is there going to be, you know, even if it's slightly categorized, like an improve a messy bookshelf over a garbage bag, like, like can we stack as far as prioritization of like what data is most relevant for us to keep and try to continue working with in a productive way versus things where we know that there's an alarming amount of duplicates and false data entries, or we're just not really sure what happened in this bag that we have, so to speak.
We only curate the large things that we know about already. So we have AlphaFold and we let everyone know that there is a single set of the AlphaFold data sets, and you should just access it read only and not download your own. Same with the Llama. We've got a collection of those, but we don't do anything about people who kind of bring their own in that are not already common.
So on that note, do any of you have a formalized structure for hosting centralized data sets? Or I guess, Chris, how do you do that?
We have a file system called contrib, and then there are directories in that, and we can make them read only, or we can make them group ownership. So if a particular group has access to some RedCap data or something that's proprietary or restricted, we can put it in that contrib file system and set the permissions accordingly. So um, AlphaFold is read only for everyone, but then some of the restricted ones are read only to the group.
Okay, fascinating.
We
That sounds
tend to make
wonderful.
directories for groups and give them permission to those directories for mostly for read only. That's what we tend to do.
Is that like on a manual request basis then?
Right. Yeah, it's not something we're sensing a need for and then putting in place. It's usually from a meeting with the group itself or the PI in charge of that group.
Okay. Stephen, you were going to say something?
I was just thinking about how wonderful having like a central kind of sharing platform like that for read-only access would be. I think currently, similar to Evan, the description of, project by project basis, we have those conversations. It's then we need to, I mentioned reviewing monthly the access controls again for some of these. It's a little bit more overhead on our end. And, we have some offering for university-wide read-only access to grow the reputable data set.
Okay. Any other comments on data management or storage? One of the Ritu had a question, said, how do you decide which data sets are centrally available? So I know Evan said based on request. Chris, do you?
Kind of the same. If we've heard of it or we Google it and we go, oh, that looks useful. They're usually not that big. AlphaFold is the exception. It's very big, but it's well known and it's got a very good value case. So sure, we'll put that there. And we want to prevent proliferation of large data sets. So um, it's in our benefit to provide them pretty much upon request, especially if they are standard well known.
Any other insights on how you may or may not host data sets? No. I guess, Anna, if you don't mind me picking on you, from a faculty member's perspective, what are things like centralized data sets that you wish that were offered that may not currently be?
Honestly, all of us do something so different that I don't really know of any centralized data sets other than it's central for that faculty member and maybe the researchers that they work with at other institutions.
Okay.
And then it's a matter of trying to be able to share across institutions. And some institutions lock their network down a hell of a lot more than others where you can't share anything because students come first. So that's usually the bottleneck that we're hitting is just being able to actually get anything to and from places. But however, if you're going to have something centrally located, I would say 4 terabytes of a torrent, that'd be kind of nice to be able to have access to, because from a faculty member's perspective, it'd say, well, if I'm not allowed to download it, how about you download it? You download it, you do whatever it is that you need to do, just tell me where it is, and then I'll use it. And they don't necessarily understand all the nuances behind security and IT and everything else of here's why that's still potentially a problem, or here's how we can or cannot work around that. But we're always looking for angles of how to work around limitations that are put in front of us.
Yeah. Okay. I appreciate that insight. Um, I just want to remind our attendees, if you have questions, feel free to speak up, put them in the chat, raise your hand. We would love to hear it. Um, what are some key trade-offs when designing? Oh, okay. Chris posted the list of his data sets in the chat. So anybody who's interested in that, thank you, Chris. What are some key trade-offs when designing scalable HPC systems? So for example, performance versus energy efficiency versus cost. So one of our researchers, when we were working with a project, very large data needs. So they were using very fine microscopy. I can't tell you the examples because I am not that domain scientist, but they were talking at a very large ingress rate. So we were talking maybe 4 petabytes a month worth of data coming in. And at the time, we were trying to come up with a solution to make a storage solution that we could eventually, keep adding on to build over the years. Are there other structures that you have in place that allows you that sort of adaptability, I guess? Do you just deploy a cluster and then wait till its end of life and do a brand new one?
It feels like it. I think from our perspective, cost recently has been terrible, right? With
Yeah,
changes in hardware demand and things like that, and everything else kind of stacked on top of it. But we looked at it at how to optimize the efficiency of the system as sort of the best way to affect all three of those kind of legs at the same time. Um, and so, like, if we can better optimize how the researcher is handling their work, if we can help, educate folks as far as, you requested one core or you requested 20, but you only ran one core, and things of that nature, the better we can kind of handle that part, the sharper our utilization is of the system. And so are we at a point where, hitting the 70 to 80% utilization is still as practical as I thought it was before? Maybe not. Like now I feel like I need to be targeting in the 90s, and then if I miss a little bit, that's understandable, but like how can I help these researchers be as efficient with the computation as possible? So it's a lot of like reporting and facilitation work that we focused on as far as where to spend those funds.
absolutely.
So the answer to your question, Carrie, was yes. We just provide a general purpose supercomputer that can do everything okay or quite well, but nothing perfectly. And that meets the vast majority of our needs. If there's someone who really wants to use FPGAs or a Maverick coprocessor, we'll help them get access to ACES at Texas A&M or any of the other access systems. If they're doing particular classroom work that we can't support, like instant response for a student in a classroom while the class is being run, Jetstream. So for anything that's not standard for us, we really work hard to get them onto an access. It's free, right, Henry? So those resources are wonderful. Lets us just address the 80-20 rule of we can support most research computation.
Absolutely. I think we do the same thing. We try to stay as middle of the road as we can. But you definitely have those groups that have specialized needs that just need exactly so much memory or, a specific model of GPU.
Yeah, we had a researcher. We allow researchers to buy into our system, but we require them to buy the same nodes that we buy, so it becomes a pool of everything the same. But
Yes.
one of them insisted that he needed compute nodes that had 8 core processors that ran at greater than 3 gigahertz because that's the only way his code would really run well. Yeah, that frown expression you just did, Carrie, that's what we did. And we're like, no, that's not how it is. And, no, no, that's really it. So we accepted and we allowed him to purchase 8 core processors with 3.5 gigahertz or something performance. And his research team, after all, just started using ours because they didn't have enough cores on theirs, and ours worked fine. So sometimes they insist, and if they carry, if they come bearing buckets of money, that we have to pay attention.
Yeah, absolutely. It's those with the wallets, right?
Yes. Mhm.
Uh, um, so once again, I'm going to query the audience. Do you guys have any questions you want to ask our panelists today on how to assess and anticipate researcher needs? All right. I'm trying. So I guess I have one more question. What role does containerization and orchestration tools play in modern HPC environments? And do you use them at your institution?
We had a plan to do that, and I guess still kind of have a plan to use Kubernetes, but we're really just not there yet. And it's kind of a problem I described a little earlier, which is with a smaller staff, just being able to queue things up and getting it in place and learn everything you need to learn to do something a little differently has been kind of a longer path than I would have expected. But it really had we were focused and for a lot of that time though on one thing I wanted to mention was, you know, we we take whatever equipment we can get almost whenever we can get it. Yes, it might be the new shiny cluster, but we take donations sometimes. And for example, we took a donation, an older supercomputer from a Air Force base, and integrated that into our other cluster. But so we get involved in that sort of thing, and you put a lot of time and effort into doing that. And that had been our plan was to really segregate out services and make each of those a container. And I think we're still on the road to doing that, but that's where we are with that.
I've looked into Kubernetes on and off over the years, and we just don't have the staff to make it work. But Jetstream does, and they do a great job with that. So if you really want to use Kubernetes and let people have system authorization to run their compute nodes, Jetstream will do that. We have been using Singularity, now Aptana, for many years and think it's great. It's especially good for two things. If you want to package up your workload so that it's reproducible, it does that very well. And then also it'll do codes that your system doesn't handle right anymore because libraries have changed. So you can preserve your environment. So I think containers are great. I know some institutions like Utah have all of their apps are containers. And so you can do that too, but we don't.
Do you guys have a lot of user uptake on your containers? Like, do a lot of your users run jobs in their own containers? And if so, how do you think you combated that barrier? Because I don't have a lot of luck talking people into using them who don't have any experience with it. So
We do have to handhold them. It's a
yeah.
lot easier for some of the machine learning types. So we have a container for PyTorch because it's got a lot of dependencies to create it. So it's easy just to create it for them and create an alias. So they do module load PyTorch and they don't know they're actually um, opening a container. So some of those things we can do for them. Often they're really smart and they get the concept. They know the limitation of what it won't do, and they're like, "Oh, I could do that." And then they'll just, with some help, they'll create a container and use it. It's once you get it, it's not that hard. It's just getting to that point of understanding conceptually what it does and how to
Yeah,
put the things in it that you want to be there.
absolutely. Stephen, did you have anything to say even about the previous?
Yeah, I agree on the points about Singularity and Apptainer being wonderful resources for researchers and on orchestration. Um, I would say hmm, for the containerization, personal opinion here, am sometimes a little nervous about it, and I'd like to ask the panelists a little bit about it as well. I sometimes am concerned that it allows for researchers to stay with the same software versioning when in theory, in the to the benefit of research and being able to scale better, they would want to, I mean, they would want to, we would want to have them kind of upgrade to different versions of software and different practices. I see the head shake. I see it. Um, and so like I'm touching on it lightly, right? But I'm just thinking it's possible that as a graduate student, you could build a container and just attempt to just ride that out to retirement, right? And so like I don't want to ever see that happen. And so, this wasn't a problem, 10 or 15 years ago, but it's something that could be considered today is that you could just stay with one version as best you can. And just like we, kind of squashed Windows 98 and Windows 2000 and et cetera on our campus, right? Like at some point there's going to be an awkward conversation about that containerized spec. And so that's why I kind of again just wanted to gently ask if there was anything as far as following up with folks about their containerization.
They may hit a limit when the underlying kernel changes and the container will
Right.
no longer run. So if they hit that, they're done for. They need to upgrade it. But at least they should have a recipe that they could reproduce and then just get a new version. So the same libraries, just different versions of them. Get a new NumPy, pandas, whatever they're using.
Yeah.
Okay.
Because honestly, if it's not causing us problems, we
Mhm.
hate updates
Mhm.
with a passion. Because why did this stupid thing break? It's a JavaScript library I don't even use. None of the stuff I use uses it, but it happens to be there. Now I have to update it, which is going to break everything for no
Yes.
apparent reason. And now I have to spend weeks trying to figure out what the hell happened because of an update I did not need. So that would be one of those
Mhm.
friction points that would actually be really nice to get rid of. And then when it's a, oh, hey, here's a container that a grad student figured out how to update and everything already works on it, fantastic. Let's use that. But we're not having to go through those growing pains constantly all the time because some update had to happen.
Yeah.
Yeah.
I greatly appreciate your perspective here, Anna. Thank you so much for sharing that.
Is there a way to like help, I don't know, navigate or choose like when that friction or pain occurs? I'm just thinking, you get the Windows update when you're giving a presentation that says reboot now, right? Like that happens to me in today's day and age all the time. And like the containerization, like we need to do an update right before publication or right before a big task would be terrible. So I'm just trying to think of, I don't know how to describe that.
The way we handle
Between
it,
projects, honestly,
Yeah.
yeah,
between projects,
Okay.
because
yeah,
our computers don't, unless we're on a Mac, in which case we get forced upgrades, and that's a pain in the ass. But the Windows
Yeah.
computers in the labs on campus, they're completely set off from any kind of updates throughout the entire academic year. And a Windows update accidentally snuck through over Thanksgiving break, and it broke a bunch of fundamental processes in basic software that's used in some of our departments, and it actually affected state agencies because it snuck through their systems too. So that's the glorious thing of collaboration of, hey, this basic fundamental thing in a software we use all the time is now broken because of a Windows update. Thanks. But you have a giant community to basically start asking them what happened. Somebody figures it out and then just kind of starts passing along. But when you're a single researcher, or maybe three, and all of a sudden there's an update of some kind, you don't even know what it was. And then it's a, oh, thank you, Linux. That was incredibly helpful. Now let me figure out what the hell happened. And it might not even be something that they can fix because of the software that they're using and they have to wait for a patch, but they don't want to wait for a patch because I have a presentation that I have to do in 5 days and I need to finish running my extracts and all of that stuff. And being able to have that container where that stuff isn't going to happen, that's how you sell researchers on it. No updates are going to happen in this container until you're ready for them to happen. They'll be like, yeah, sure, sign me up, whatever I need to do for it.
Mhm.
What we do, and this is not a container-based problem, is whenever we have an outage, we have one of our software engineers go to the person's lab and help them make sure everything is up and running shortly afterwards. We have a copy of their code, we test it. It's a lot of effort, but it really has been the only thing that has allowed us to maintain everybody's sanity. Um, so that's my tip. We are quickly approaching the end of our time. I want to just give this last 2 minutes for any last thoughts that you panelists have to share. Otherwise, I'm going to air horn cut you off as soon as we hit 5:29 Eastern.
Just to wrap up one of something I made a note of prior to this about how to anticipate researchers' needs. Whenever possible, I get to do the faculty recruitment tour, and I give them a tour of our HPC center. So these recruits are usually highly recruited, and they come with startup packages. And to know what they are interested in is valuable information for me, and it helps me to sell them on that we have what they need. Um, the other thing that I've only done once and I want to do it regularly is just do a Qualtrics survey of our researchers and just ask them 5 questions. So the one persistent question might be, how do you rate what we are doing? And just give them a Likert scale. But then whatever the subject of the day is, like, are you interested in GPUs, AI, whatever it is, and just get their feedback and have a one or two open entries that they can put in whatever.
Love that idea. Anybody else? All
We've
right.
been doing those Qualtrics surveys periodically too to try to get that similar kinds of information, and it's very helpful. Sometimes folks don't want to tell you in person some negative things, or they forget things to mention to you also. So I think those are valuable.
All right. Thank you both. I want to thank all of our attendees today and all of our panelists. Um, that's an excellent question, Ritu. If I figure it out, I will email
Keep
you
them
and let
short.
you know. But thank you all for your time today. And I'm assuming there's things happening tomorrow, right? Because we're not over yet, right?
That's right.
Excellent. So I hope everybody joins us again tomorrow and have a wonderful evening.
Thank you. Let's give our panel a round of virtual applause. And I'm going to shut off the recording.